Hi guys, welcome to this video, and today I will be talking about our presentation for the Minnesota State Science Fair, and this is about keeping our environment clean. Unfortunately, my partner Cesar isn't here today, so I will be doing the video by myself. Enjoy. Keeping our environment clean by Loujane, Omar, and Cesar Rios-Rodriguez. Introduction or research question. For me and Cesar's science experiment, we will be trying to find out which types of cleaning methods work better for keeping away bacteria and keeping us safe. We are trying to answer this question because of the recent rise of sicknesses like COVID-19, the flu, and RSV. So to keep these illnesses away, we have to take proper safety measurements, especially in schools and hospitals. Hypothesis. We think that our school's method, which is chemical number 41, will work the best because it is a pre-made solution that our school orders from our online website called 3MTM. Another reason we think this solution will work the best is because it contains ingredients like diacetyl dimethyl ammonium chloride and dimethyl benzene ammonium chloride, which are known for killing bacteria and keeping surfaces clean and sanitized. Materials. We use petri dishes, agar, number 41 solution, water, soap, an incubator, E. coli, parafilm, and cotton discs. Procedures. To conduct our experiment, we poured agar into a petri dish and split it into quadrants. We then poured number 41, water, and soap plus water in their own petri dish. Then we placed 4 cotton discs in each petri dish and let them soak for 5 minutes. After that, we slapped some E. coli and pasted it on the petri dish. And then after placing the E. coli on the petri dish, we picked up the cotton discs and placed them in their own quadrant on their designated petri dish. We then sealed them up with parafilm and placed them in the incubator at 37 degrees Fahrenheit. After 1 week, we measured our results. Distance from solution to bacteria in millimeters. So, our first solution was water, and for all 4 measurements, we had 0 millimeters of distance. Our second solution was the number 41 solution, and for our first measurement, we got 1 millimeters. Our second measurement, we got 1.5 millimeters. Third measurement, we got 0.5 millimeters, and our fourth measurement, we got 1 millimeter. For our last and final solution, which was soap and water, we got 3 millimeters for the first solution, for the first measurement, 3.5 millimeters for the second measurement, 4 millimeters for the third measurement, and 3 millimeters for the fourth measurement. Our average distance from our solution to bacteria was 0 millimeters for water, 1 millimeter for the number 41 solution, and 3.375 millimeters for soap and water. Conclusion. We conclude that from our data, soap and water did better than the number 41 solution and plain water because it was the farthest distance away from the bacteria than the number 41 solution in the water, which means it killed more bacteria than the rest. We also conclude that it is safer to use soap and water than to use plain water because it kills more bacteria. Here are our pictures. So as you can see, the soap and water has a bigger halo around it than the number 41 solution, which means it probably killed more bacteria because it's a farther distance away. So we can tell that the soap and water did better than the 41 solution. So that's soap and water, and that's 41 solution. Our next set of pictures is the water in all 3 discs. So as you can see, the water had no halo around it, which means it didn't cause anything. So it didn't impact the bacteria at all. And then there's a picture of all 3 discs as a comparison of how it looked like. Thank you for listening, and here's our contact information. You can always email us or text us, like at these emails or numbers. Like, give us your feedback. We would love it. But thank you for listening. Bye.